All right, section 3.6. Is this the last section of the chapter? I think it is. Yep. This is the very last section. So guess what we're ready for?
A test.
Ready for a test. Yeah, we'll probably have it. Probably have it sometime next week. I would say probably middle of the week next week. All right, because the marking periods. Shh, why are we talking? Why are we talking? I'm talking. We'll probably have a test middle of next week. All right, not sure exactly what day. Just depends on how fast we go this week, that kind of thing. All right, but the middle of next week. And the marking period closes Friday of next week. All right, so we have a short week this way. We're only to Wednesday this week. And then we have all of next week, and that's the last week of the marking period. Okay, let's do this. Let me give you a little definition first. If I said, let's pretend this is the ground, okay? And you're in an airplane up here. Watch my cool airplane. Let's see my airplane. Look at that. It's like a jet plane.
That's gorgeous.
Isn't that cool looking? There's the cockpit right there. See the pilots in there waving to you? All right. Yeah, I'm no artist, as you can tell. But that's okay. I can draw a bunch of triangles, kind of make it look like an airplane. All right, so this is an airplane's going this way. And the pilot says, okay, we are now, 30,000 feet. We're at an elevation of 30,000 feet. Well, what's he talking about as far as 30,000 feet? 30,000 feet from where? Well, hopefully we understand starting at where the airplane is. All right, is it like 30,000 feet to where you'll want to end up? Is it 30,000 feet from where you started? Where is it? From the ground, right? Well, that's to the ground. Is that the 30,000 feet that he's talking about? Thank you. Perpendicular. That's what I was going to say. A lot of people always say straight down, and I heard that already. Straight down. And technically, I agree with you. Straight down. But if we're going to get a little more geometric in our language right here, we're going to say that it's perpendicular. Okay? So when I have a certain point, okay, pretend that where the airplane is just a point. If I say, what is the distance from a point to a line, and we'll pretend that the ground is our line, all right? What is the distance from a point to the line? Which distance is it? Is it this slanted distance? No, it's the what? It's the perpendicular distance, exactly right. So that's pretty important. You may look at that and say, well, of course, that kind of makes sense, but it's the distance between a point, oops, it's supposed to be a point, and a line. Alright, so the distance between a point and a line is the what? Is the perpendicular distance. Everybody see that? So it's from that point perpendicular to that line. So that right there is the distance. D-I-S-T. Looks like dirt, doesn't it? It's a distance. Right at the whole thing. My writing's terrible today. Alright, so that's the distance right there. That's D. Make sense? Alright, so what if we did this? What if I had a point out here and I had a line like that? And if I asked you to come up here and draw the distance between this point and that line, how would you draw it? You'd go from here, down to the bottom? Is that what you said? Up to the top? Tell me when. Tell me when. When it looks perpendicular. That's a good way to say it. Is that? Yeah, when it makes 90-degree angle or it's perpendicular, right. So that looks pretty close to perpendicular, doesn't it? Alright, now I'm just eyeballing that, but there we go. So that blue line right there would be the what? The distance between what? The point and the line. That's right. Okay, the distance between a point and a line is the perpendicular distance. That's very, very important for what we're going to do today. All right, we're going to put some math. We're going to put some numbers in there. Don't worry. All right, but you got to first understand what it means to find the distance between a point and a line. Make sense? There's another part of it. I think I'll wait till tomorrow to do that second part. We're just going to stick with a point and a line right now. All right? That's supposed to be a box. Yeah, I just kind of curved it a little bit. But that's supposed to be a 90-degree angle right there. Okay? Everybody okay with that? Alright, so that's the distance between a point and a line. It's the perpendicular distance. Alright, Glad you got that. Let's, I tell you what, let's chuck a triangle in here. Let me get a triangle. Let's get this nice triangle right here. And let's scooch down again. Put it right here, make it a little bit bigger. And if I told you to sketch a line that represents the distance from point A to line segment BC. So if I told you, I gave you this triangle, this in yellow, and I told you to sketch the length from point A to BC. So you're from A, so you're going to be right here, right? So where are you going to go? You're going to go to B. Is that the distance from A to line BC? Is it going to go here? Where's it going to go? It's going to go from A what? The point perpendicular. That's right. Perpendicular, okay, to that line that you're trying to find right there. Everybody see that? So that yellow right there, that's the distance from point A to line or line segment BC. Make sense? All right. Not hard, but I'm trying to really get you to understand what you're finding when you're finding the distance. What if I wanted to go from point C to line AB? I'd start at C. Where would I go? I know you said this 10 times, you're getting tired of it, but where will you go? You go what? Not straight. Let's not say straight. Perpendicular to AB, right? So draw a line that's perpendicular from C to AB. So that red one right there would be the distance from point C to line AB. I'm actually getting a little ahead of myself, but this is good sneak preview. We're actually going to have a lesson in another chapter. Forget which chapter it is. It might be the next one. I can't remember. But watch this. This is kind of fun. What if you went from B to AC? It would be the perpendicular distance again, wouldn't it? But watch this. What's cool about this is if I found the distance between them all, look what it does. It actually meets at one point. That's pretty cool. All three lines actually meet at the same point. It's got a special name for it and all that kind of stuff, and we got some words. We have some words for it, all this kind of cool stuff. We'll learn about that in another chapter, okay? But that's a sneak preview. Is that all right? But what did we just do? We found the distance between A and BC, didn't we? We found the distance between B and AC. And then we found the distance between point C and AB. You okay with that? What if you had... I got to finish doing this because I've got more important things to cover. Oh, how do I get... I'll just do this. Let's do an obtuse triangle. Now, on that one, that was an acute triangle. Where did they all meet? Where did all three of those lines meet? Inside, right, somewhere inside of that triangle, right? What if we did this, though? Let's do another color here. Let's go orange this time. We'll go green next. What if I went from this point, let's label it A, B, C. What if I went from point B to AC, and I wanted to find the distance from point A to point AC? What would I do? I'd go perpendicular, right? That looks pretty close to perpendicular. Right there. What if I wanted to go to A to BC? Now this is where it gets a little bit tricky. If I wanted to go from A, I got to go perpendicular to BC. Is that perpendicular? What if I go up there? Am I going to get perpendicular? It's actually getting worse and worse, isn't it? As the further I go up. Guess where I'm going to have to go? I'm going to have to go... Oops, sorry. Let's do this real quick. Watch. What am I going to have to do to this side right here? Extend it. Very good. I'm going to have to extend it so that I can actually hit that. You want a green for this one? Alright. Which green? That green? Alright, so watch. Now look, I couldn't go perpendicular here, 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 or even up there, could I? So I'm going to have to go perpendicular way down here like this. Does that look close to perpendicular? Pretty close. Right there. You see that? So I'd actually have to extend this, wouldn't I? You want to do one more? Just for fun? Let's go purple this time. Let's go from C. Now watch. If I go from C, can I go perpendicular here? Can I go perpendicular here? Here. No. What am I going to have to do? I'm going to have to extend it again, right, out like this. So watch. I'm going to have to take this side, and I'm going to have to extend this side out. And now I can go ahead. What color was I? Purple, right? Now I can do this. I can go from here and go perpendicular to it right there. Ah, it's a good question. I'm glad you asked that. Yeah. Right. Watch this. Now, I wasn't real careful. Some of these I just eyeballed them, right, to see if they're perpendicular. So it might be off a little bit, but if you were really, really careful to make sure that it was 90-degree angle and perpendicular, you should see something. Watch. Extend this. Extend this one. And then, now look, any two lines are always going to intersect, aren't they? Oh, I was pretty close. That's not too bad for just eyeballing. Now, if I was dead on, what do you think would happen? They would actually meet at one point. I was pretty close for just eyeballing a couple of those. All right, and they actually intersect at one point. It's kind of cool, isn't it? All right, so there you go. But that's for another time. All I want you to do is understand the thing about the distance. Let's actually do some stuff now. Nah, you don't need to know that. All I was trying to get you to understand was to go from one point perpendicular to an opposite side. Okay, and I think I ran that into the ground enough. Let's do a problem. Yep. Yeah. All right, I'm looking at page 215. It's an example, and let's write it down. It says line L contains these 2 points. And it would be -5, 3 and 4, -6. Alright? Question says, find the distance. Now we know how to draw it now, don't we? All that stuff that we did beforehand was just making sure that you knew what you're asking for when it said find the distance between a point and a line. But this time we're actually putting numbers to it. So find the distance between line L and a point, which is point P, and it's 2, 4. Okay? Now, you don't really need graph paper to do this. I mean, it might be a little helpful, but you don't need to. This doesn't have to be dead on exact. The graph is just to kind of help us out a little bit, give us a little bit of visual idea of what's going on, what we're actually trying to find. All right. So line L contains these 3 points, or these 2 points right here. So let's graph them. -5, 3. 1, 2, 3, 4, 5. 3, 1, 2, 3. All right. So that's 1 point. -5, 3. The other is 4, -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4, -6 would be about right there. Now, it says that's a line, isn't it? So what do you think I want to do now? Draw a line. Good idea. All right. Let's go green. So I'm going to connect the 2 points. I'm even going to extend this side out just a little bit. It doesn't have to just go between those 2 points, but that would be the line that contains those 2 points. Agreed with that? All right. Again, this doesn't have to be a perfect graph. It doesn't have to be done on graph paper. No. I got to find the distance between line L, this is line L, and another point. What's the point? 2, 4, right? So let's put another thing right there. And 2, 4. So 2, 4 would be right there. So that's point P, which is at 2, 4. So what are they asking you to do? Let's go purple. Actually, let's go red. And we'll make it a little thicker so it stands out. What do they want you to do? They want you to find the distance between this green line and this point. So let's draw it, just like we spent the last 10 minutes doing, okay? We go from here, where? Perpendicular, right, to that line. Do you agree? Yeah. Okay. Problem is, that doesn't look perpendicular? It might be off a little bit. Where it has to go up here a little bit? About right there? Yeah. Does that look better? Okay. Doesn't have to be exact, all right? Doesn't have to be dead on exact. Now, if you use graph paper, that could be helpful to you, but it looks something like that. Would you agree? Yes. Well, there is an exact. Like right here? Well, it just has to be perpendicular to this. Okay? So this red line has to be perpendicular to the green line. Now, we're not really sure where it's going to hit the green line right now, are we? Not yet. But we can actually figure out where that point is. Because what are we trying to do? We're trying to find the what? The distance between what? This point and what else do you think? How about this point right here? Well, and the line, but we want to find the distance between this point and this point. Does that make sense? Because this is the point where it's perpendicular to. So I don't know what this point is. I can kind of guess. I might be able to just look at my graph and guess, but I don't want to guess. I want to make sure that I get the exact number, all right? Because sometimes my graphs are a little sloppy. Even using graph paper, sometimes you may not, draw your lines exactly the way it's supposed to be. So I got to find this point. Don't know what it is. So let's call it XY. Is that all right? That's what we're going to try to find. So I want to find this point. Once I get that point right there, once I know this point, how could I find the distance of that red line? Distance formula, exactly right. Make sense? That's why we learned that stuff earlier, right? So I got to find the point. So the whole gist of this problem right here is to find what that point is. So how do we find that point? Do we just guess where we think it should be? Nah, that's not a good idea. Justin, what do you think you might do? Okay, so why do we even care about the slope of this? Yeah, and that helps us find this point right here. Exactly right. So you probably thought, well, how does slopes ever come into this? Well, remember about equations of a line and all that kind of thing? I'll show you this. Watch. Do you see this point? This is the point of intersection. Yeah, they are. You're right. I know what you're saying. This right here is the point of intersection between those two lines. So guess what? This XY right here is on the green line, and it's also on the red line, isn't it? That point of intersection is shared by both lines. That's very, very important to understand. That point of intersection is shared by both lines. That means both lines have that exact same point. I'll show you what we're going to do here in a second. Okay? So what I'm going to do is I want to actually find the equation of both of the lines. All right? The green line I should be able to do. Actually, let's do it in green. Okay? Let's find the equation of that green line right there. All right? Well, I know that. Actually, scooch it up a little bit. All right? So I know this. So what can I find? I can find. Watch your foot on my cord. All right? I can find the slope. So let's do that real quick. So the slope is change in y over change in x. So it's 3 minus negative 6 over change in x, negative 5 minus 4. What's that? 9 over negative 9. So what's the slope of that green line? It's negative 1. Okay, that's the slope of this green line. So what do you think the slope of this line right here is going to be? The red one. If the slope of the green one is negative 1, remember they're perpendicular to each other. It's positive 1. That's right. It's positive 1. It's the negative reciprocal, right? We flip it, it's still 1, but we change the opposite. We change the sign, and it's positive 1. So that's going to help us out a little bit. All right, but let's continue with the green one. Let's find where the y-intercept is. Okay, I might have not drawn this perfect, but let's find out what the y-intercept is. Yes. Yeah, it's just the two things, yeah. All right, so let's see what I want to do. Y equals mx plus b, right? Well, what do I know? Do I know a x and a y? Yeah, I could use either this one or this one. It doesn't matter which one. Which one do you want to use? 4, negative 6? Okay, so the y is negative 6 equals the slope. Just found the slope. What is it? Negative 1 times x. What's the x? If I use negative 6 as my y, I have to use 4 because that's that point plus b. Now I can solve for b. So negative 6 equals negative 4 plus b, and b is out of 4, what do you get? Negative 2. Now, it didn't look like it. See, I just kind of eyeballed these points, right? It doesn't look like it crosses exactly negative 2. If you would have used graph paper, you probably would have got a little bit closer. But that's pretty close, isn't it? I was kind of close. All right? But this tells you exactly what it should be. So it's negative 2. So let's write down the equation. Y equals negative x minus 2. I like to do this. I like to put this one in a box. We're going to hang on to it. We're going to use it here in a second. Remember what I said earlier? You might have missed it, but I said we're going to find the equation of both of those lines because that's what the slope of it was. The slope of the green line was -1 right here, so it's -1x. Well, yeah, I just took the 1 out. I don't need the 1. All right, it's -1x or just -x. All right, so I found the equation of the green line. What's the second thing I said we were going to do? Find the equation of the red line. Okay, red lion. Okay, so let's find the equation of this red line right here. Do I know the slope of the red line? Yeah, because I know the slope of the green one. What's the slope of the red one? We talked about that a second ago. It's +1. Very good. Now, we can find the equation of it by going again, y equals mx plus b. Which point am I going to use for this, though? I'm going to use the one they gave us. That's right. Okay, I'm going to use this one. That's the only point I know on that red line right now, isn't it? All right, so let's plug it in. What do I put in for y? 4. What do I put in for m? Now, look, m. Okay, m, not x, for m. Put a 1. And then x.
Do you have Stephen Choi?
I do.
Press him for a minute, please.
Okay.
Thank you.
So x is what? Now it's 2, right? Plus b. Don't know what it is. So this is 2. Subtract 2. What's b? It's just 2. So what's the equation of that red line? Y equals x plus 2. Very good. I'm going to put a box around that. So I'm going to use these two things in boxes now. All right? It's not done. We're close. We're real close. Kind of. Yep. But if you look at the homework, I don't give you that many of them. I only give you like 4 or 5 of them. Yeah, I only give you like 4 or 5 of these. Now watch. So what did we do? Let's review very quickly. First thing we did, okay, we graphed it, right? We saw what was going on, okay? So what do? We took the one line that they give us, and we found the equation of that line, right? Found the slope, then the y-intercept, boom, got the equation of a line. Then we did the same thing for the other line, okay? So we know what the slope is on this one. It's perpendicular, so it's just a negative reciprocal. That wasn't that hard. Plug in the x and y, bang, you got it. I took a long time explaining it, but it won't take half that long. It won't even take half that long to actually do it, all right? So you've got these two equations right here. Now remember, we're trying to find this point, aren't we? So we're trying to find this point. This point, now this is very, very important. This point right here is in common with the green line and the red line. It's shared. Okay, so the same x and y on the green one is shared by the x and y on the red one. So look what we're going to do. Look at these two equations. They're both equal to y, aren't they? This is equal to y, and this is equal to y. Well, if they're both equal to y, then they're both equal to each other. Very good. That's what I was looking for. Okay, look. So look, this is equal to y, and so is this. Would you agree? And what am I trying to do? I'm trying to find this x and y right here. I'm trying to find the point that's in common, that is shared by both of those points. So watch what I'm going to do. This is just Algebra 1 stuff right now. Watch. They're both equal to each other then. That's just a simple substitution. So watch what I'm going to do. I'm going to go x plus 2 equals, what do you think? Negative x minus y. Because look, this is equal to y, this is equal to y. So if they're both equal to y, they're both equal to each other. So I'm going to set these equal to each other. So x plus 2 equals negative x minus 2. Let's solve for x. Once I solve for x, guess what I just found? I found that x right there. Okay, so let's do that. Add an x to both sides, subtract a 2 from both sides. We get 2x equals negative 4. So what's x equal to? Negative 2. That's right. Just watch how I do it. Just watch how I do it. Okay? So what did I just find right there? I found that x point. And that makes sense, doesn't it? It looks like it goes over negative 2, doesn't it? Now I just got to figure out what my y is. Now I could just look at the graph and make a guess, but that's not really the best thing to do. So now I can find y. I can put this negative 2 either in for x on this one or x here. It doesn't make any difference because they're both equal to the same y. Let's pick this one right here. So y equals what? X, which is negative 2 plus 2. So what's y equal to? It's actually equal to 0. On my graph, it wasn't that accurate, was it? This point should be right here. All right, but that's okay. It doesn't have to be perfectly accurate. That picture was there just to give me a general idea what was going on. So now I found this point. I found this x and y. So what is it? It's -2, 0. That was the bulk of the work. That was the bulk of the work. We're still not done. Right, so now we got to actually find what we were looking for at the beginning. Listen to what I'm saying. Of course we're not done because we haven't found the distance. All we did, all right, I'll do different color. Look, let's just listen. So now I found that point right there. That was very, very important for us to find because I want to find the distance between these 2 points. All right, the distance part, that's the easiest part of the whole thing. All right, so what are my 2 points then? It was 2, 4, right? Was the point they gave us. And what's the point that we found? -2, 0. I said I was going to do this in a different color, didn't I? What color? Blue? Light blue? Okay, there's light blue. All right, so here's the 2 points. Do you see where I got those 2 points from? One was already given to us. We had to do all that work just to find that point right there. But I found it, didn't I? All right, so now we just find the distance between those 2. So let's do it. That should be easy. Distance equals big old square root. See, this is easy now, isn't it? Oops, almost forgot something, didn't I? Put a plus here. And how do we find the distance? Subtract the x's from each other. So 2 minus -2, and then 4 minus 0. Doesn't matter what order. Okay, as long as you just subtract the x's from each other and the y's from each other. So that's 2 plus 2, right? 4 squared is 16. Plus 4 squared again is 16. What is that? The square root of 32. Okay? Or you could say 4 square root of 2. Do you guys remember how to do that in Algebra 1?
I was not good with that stuff.
Because 16 times 2 is 32. The square root of 16 is 4. Okay? We'll probably put it in a... They do both. They say you could write it like this, or you could put it into a calculator and get an answer as well. So square root of 32, right? Square root 32, and that's about 5.7. Is that right? Now they take it 2 decimal places. It doesn't matter. Let's go 66. So 5.66. Either one of those, I'd be perfectly fine with.
5.66.
So what did we just find? What's that 5.66 represent? The distance. How long that line is. That line is 5.66. Let's review briefly. Just a snapshot review. Are you ready? Here we go. It took a little while, but I sat here and I explained every step. Okay, you cut the time in at least by half or a quarter if you're doing it on your own, if you know what you're doing. Right. So look what we did. First thing we did, we drew it out, didn't we? Everybody, let's not pack up. Let's everybody listen real quick. Little snapshot review here. We drew the thing out. We saw we had 2 lines, didn't we? We had to draw that line to here. So we found the equation of one line, found the equation of the other line. Okay, then after that...
Hamrick,
Yes?
can we have Brooke pull Herrick for an early dismissal, please?
Okay. So look, these 2 lines right here, I found the equation of the 2 lines. Then what did I do with them? I set them equal to each other, didn't I? That was actually pretty easy. The hardest part is just finding the equation of the 2 lines. After you do that, you set them equal to each other, and I solve for x. Once I get x, I put it into either this one or this one, doesn't matter, and you solve for y. And then you got your point. So there's the original point they gave us. Here's the one that we just found. Find the distance between them. Bang, you're done. It's as easy as that.
And then put it into distance.
Yeah, that's the bang, you're done. You got to put in the distance, and then you're finished. All right? So if you look at it that way, it really wasn't quite that bad. It was a little bit of work finding the equation of this line, a little bit of work finding the equation of this line. Right, it's not really that difficult. Okay, so let's think of this. Let's think of drawing the thing out as one step. Finding this equation, we'll call that step 2. This equation, step 3. Solving for x and y, I'll put that in one, we'll say that's step 4. And then the distance formula, step 5. So I would say 5 steps, wouldn't you? Yep, let's give you some homework. So it's section, now I'm splitting this in half, okay? So we'll call it 3-6A. And then it's page 219. And we're just going to go 15 to 20. So that's 6 problems. All right, it's only 6 problems. They are a little bit lengthy, I agree. But work on those hard, okay? Because wait till you thought that was bad. Wait till you see what we're going to do tomorrow.
I think I like that.